The next topic is domain and range. Domain, it is the set of values that the variable x can take such that the function is defined. This is very important, such that the function is defined. For instance, if we take 1 by x, we cannot take x as 0 because then it would be undefined. So therefore the domain is everything, all real values except 0. Like for example, I have given here y equals x plus 3. The domain is for all real values. You've probably learned this notation in sets. So x belongs to all real values. And similarly, range, it's the set of values that the variable y can take such that the function is defined. So for example, y equals square root of x plus 3. The range is greater than or equal to 0. We know that square root of something cannot be negative. Therefore, the range is y greater than or equal to 0. Okay, I think the book has explained really well like how to find the domain and domain and range. So therefore, I'll be looking at these examples from the book. So square root of x minus 5 is defined when this value is greater than or equal to 0. Else if it's less than 0, it's not defined because we don't know the square root of a negative number yet. So we'll have to equate that. If you find anything like this within square root, then you'll have to do this procedure. So x minus 5 is greater than or equal to 0. Therefore, x is greater than or equal to 5. And this is how you write the notation. In brackets, x dot x greater than or equal to 5, or you could just sometimes write x is greater than or equal to 5. Okay, similarly, a square root cannot be negative, and hence the range is y is greater than or equal to 0. The next example is 1 divided by x minus 5. It's defined when this is not equal to 0. It could take any value of x except x equals 5, because when x equals 5, this would be 1 divided by 0, which is, well, undefined. So the domain is everything except x equals 5. So it's true for all real values except 5. And like they said, no matter how large or small x is, y equals f of x is never 0 because, well, like it's very obvious, 1 divided by something just cannot be 0. Like if you even equate it to 0, meaning 1 equals 0, which does not make sense. So therefore the range is everything or for all real values of y except y equals 0. That's what it says. And this is the graph. As you can see, this is an asymptote. Basically, this line is approached by this but never touches this line. It's like it's infinitely close to this line, but the graph never cuts it or even touches it. Okay, the next one is a combination of these two. So it is defined when x minus 5 is greater than or equal to 0, because less than 0, first of all, the root part wouldn't work, and if it's 0, the 1 divided by 0 would not make sense, hence it's not defined. Therefore, they have stated that this is defined when x minus 5 is greater than 0, meaning x is greater than 5. So therefore, the domain is this. And as they have stated, is always positive and never 0. Like in this case, we said that it's everything except 0, right? But here, this cannot be negative because the square root part cannot be negative. So therefore, it's positive. And this cannot be 0 like I previously mentioned. And this is the graph. Okay, the next part is the modulus function, which is also known as the absolute value function. So I have just stated a few key points here. If f of x is the modulus of x, and that will equal x if x is greater than 0, minus x if x is less than 0, and 0 if x is 0. So this might be confusing, but just remove the sign on the value meaning if it's negative, it will become positive. If it's positive, it will remain positive. So I've given a few examples here. So modulus of 4 equals 4 because I've given the explanation. If you look at this, I've drawn it parallel to this. This is the reasoning since 4 is greater than 0. And modulus of minus 9 is 9 because 9 is less than 0. And modulus of 0 will be 0. It's very simple. And there are two methods of solving the equations. The book, I think, has mentioned only one of them, which is this, but you could also use this. So let's take this example. Modulus of 5x plus 7 equals 3. So for the first method, you'll have to remove the modulus symbol and put plus or minus for the whole thing that is after the equation symbol. So we write 5x plus 7 equals plus or minus 3, and implies that f of 5x plus 7 equals 3 implies 5x. By transposing this term, we can make it equal to minus 4, and then dividing both sides by 5, we get x equals minus 4 by 5. Or we could do this again, but put a minus symbol in front of this. So 5x plus 7 would equal minus 3, and then 5x would equal minus 10, and divided by 5 would be minus 2. So these two are the answers. And then there is another method, the one where you can square both sides. So 5x squared plus 7 whole squared equals 3 squared. And yeah, you just expand the what's inside the brackets and equate it, and use the quadratic formula or like splitting the middle term, and find the equation, find the roots. So either way you'll get the same answers, but I'd prefer this method because this is very lengthy and it's kind of time consuming. Plus you'll have to find out the quadratic equation, and then you'll have to solve it. So it will take more time. Therefore I prefer this method. But if you have no problem, you can do this also. Why don't you try these problems on your own, and I'll reveal the answers after you've done. So just pause the video right now and solve these, and I'll reveal the answers. Okay, these are the answers. I'll just solve one of them right now. Okay, I'll just probably solve these two. So the first equation was modulus of 3x minus 2 equals 1, I think. Yeah. This implies that 3x minus 2 equals plus or minus 1. So you can write case 1, 3x minus 2 equals 1 implies 3x equals, transposing minus 2 to this side would become 3, implies that x equals 1. And then case 2 would be 3x minus 2 equals minus 1 implies 3x equals 1, implies x equals 1 by 3. Therefore x equals 1 or x equals 1 divided by 3. The next one is this one. Yeah, we'll just solve this. This may seem complicated, but you'll have to do the same procedure. Just think of this as a constant. So if you had 1 here, you'd just do plus or minus, right? So you'll do the same thing here. 3x minus 1 equals plus or minus the whole thing, this whole thing. Case 1, 3x minus 1 equals x plus 2. Transposing it to this side would give you 2x equals 3, and then x equals 3 divided by 2. And then case 2 would be 3x minus 1 equals minus x minus 2. Always remember the multiplying rule. So this would be 4x equals minus 1 implies x equals minus 1 by 4. We got x equals minus 1 by 4 and x equals 3 by 2, which is the answer. Solve these two the same way. And then we move on to the graph of a modulus function. Basically, it is the reflection of the part of the graph which is below the x-axis, basically which has a negative y value, and you'll have to reflect it over the x-axis or take I hope you've learned the reflection thing. So the example, the book has given it really well. So here this part was below the y-axis, hence there's a, just imagine this is probably like a mirror or something, so it will form the image exactly like that side. Therefore this is the graph of the modulus of f of x. So yeah, that's basically it. If you want, you could read this, it's very informative.